Today we will be doing section 3.9, derivatives of exponential and logarithmic functions. Let's look at example 1. Use your calculator to find the derivative of y equals e to the x. So go ahead and put e to the x in y1, and then use your derivative function to find the derivative of e to the x. So when we went through and found our derivative, it should have looked like this. And it should have landed exactly on top of e to the x, meaning the derivative of e to the x is e to the x. So the derivative of e to the x, if u is a differentiable of x, then the derivative of e to the u is e to the u times the derivative of u with respect to x. Let's look at example 2. Find the derivative with respect to x of y equals e to the x to the fifth. So dy over dx would be e to the x to the fifth times the derivative of that exponent, because that's our u, which is 5x to the fourth. And that would just be your derivative. A lot of times on multiple choice, you'll see it 5x to the fourth times e to the x to the fifth. Let's find the derivative of a to the x. Use what you have learned about the derivative of y equals e to the x and the laws of exponents to find the derivative of y equals a to the x. So we know that we could use our rules of laws of exponents for, they're talking about logs here. So I know if I go ahead and took something like the natural log of a to the x, that x could come down to the front, okay? And if I want to undo the natural log, I have to use the inverse, which is e. So I could rewrite my equation, y equals a to the x, as y equals e to the natural log of a to the x. Because e to the natural log equals 1, so it's still just a to the x. So then when I find y prime, I would have e to the natural log of a to the x times the natural log of a. Therefore, my derivative is just a to the x times the natural log of a. So the derivative of a to the x, or in terms of u, if u is a differentiable function of x, and for a greater than 0 and a does not equal 1, the derivative of a to the u is a to the u, the natural log of a, times the derivative of u with respect to x. Let's go ahead and use that same process for the derivative of the natural log of x. Use what you learned about the derivative of e to the x and the derivatives of inverses to find the derivative of y equals the natural log of x. Because we know the natural log of x is the inverse of e to the x. So f inverse of x equals the natural log of x. Therefore, I use my formula for the derivative of the inverse, 1 over f prime f inverse of x. And that would be the same thing as 1 over e to the natural log of x when I go through and do all that. And that equals 1 over x. So the derivative of the natural log of x, if u is a differentiable function of x, and for u greater than 0, the derivative with respect to x of the natural log of u is 1 over u times du dx. Let's look at example 3 and do this together. Find the derivative with respect to x if y equals the natural log of 3x squared. So I have y equals the natural log of 3x squared. And to make this easier on us, we can rewrite this. The natural log of 3 plus the natural log of x squared And to go even further, this would be the natural log of 3 plus 2 natural log of x. To find y prime, or dy over dx, the natural log of 3 is a constant. Therefore, the derivative of that is 0. The natural log of the derivative of the natural log of x is just 1 over x. So this would just be 2 over x. Let's go ahead and use the same concept to find the derivative of log base a of x. So here you're going to have to use your change of base formula. We're going to have y equals the natural log of x over the natural log of a. This, we then can write 1 over the natural log of a times the natural log of x. Therefore, when I find my derivative, 1 over the natural log of a is a constant that is a factor of the natural log of x, so that just tags along, and times 1 over x, because the derivative of the natural log of x is 1 over x. Therefore, the derivative with respect to when it's in terms of u, if u is a differentiable function of x for u greater than 0, the derivative with respect to x of log base a of x is 1 over u natural log of a times du over dx, or the derivative of u with respect to x. Let's go ahead and summarize these. The derivative of e to the u is e to the u times du dx. The derivative of a to the u equals a to the u times the natural log of a times the derivative of u with respect to x. The derivative with respect to x of the natural log of u is 1 over u times the derivative of u with respect to x. And the derivative with respect to x of log base a of u is 1 over u natural log of a times the derivative of u with respect to x. All of these do need to be memorized. So continuing on with 3.9, derivatives of exponential and logarithmic functions, find the following derivatives. So take a minute, pause this video, and go ahead and work through the derivatives. The derivative with respect to x of pi to e times natural log of x would just be pi to the e natural log of x times e over x times the natural log of pi. 2, the derivative of the natural log of 5 to pi. Natural log of 5 to the pi is a constant, so this one would just be 0. The derivative with respect to x of x to the natural log of 3 would be natural log of 3 x to the natural log of 3 minus 1. And the derivative with respect to x of x to the natural log of x, what we would first have to do with this one is we would have to rewrite this as y equals x to the natural log of x, because we have two arguments, one in the numerator, one in the denominator. What I would then do is take the natural log of both sides. So I'd have the natural log of y equals the natural log of x to the natural log of x. And then using my exponent rules for logarithms, I could rewrite this, the natural log of y equals the natural log of x times the natural log of x. And then I could go ahead and take my derivative of both sides. So we'll do that over here. So my derivative of the natural log of y using implicit differentiation is 1 over y dy dx equals the derivative of the natural log of x times the natural log of x. We need to use the product rule. So it'd be the natural log of x over x plus the natural log of x over x. And then dy dx would equal y times 2 natural log of x all over x. And then going back to my original statement that I stated here, y equals x to the natural log of x. So I want this all in terms of x. So it would equal x to the natural log of x times 2 natural log of x all over x. Let's look at this example here. Consider the function y equals x to the x. So here, if I want to, and we want to find the derivative of this example. So it doesn't say that, but we want to find dy dx. Okay, currently I have a variable in the base and in the exponent, so I have to do something to rewrite this. So what you can do is you can take the natural log of both sides. So I have the natural log of y equals the natural log of x to the x. Then using my exponent rules, I'd have the natural log of y equals x natural log of x. Now I can take the derivative using implicit differentiation on the left side and the product rule on the right side. So I'd have 1 over y dy dx equals x times 1 over x plus the natural log of x. Now I would have dy dx equals y times 1 plus the natural log of x. And then going back to my original function here, y equals x to the x. So I would replace this y here with what it equals. So dy dx would equal x to the x times 1 plus the natural log of x. Logarithmic differentiation. Sometimes the properties of logarithms can be used to simplify the differentiation process, even if logarithms themselves must be introduced as a step in the process. This process is called logarithmic differentiation. So you will have to use those rules that are on your flashcards. Okay, find the derivative of the function y equals the cube root of x squared minus 2 all over 3x minus 1 times the square root of 2x plus 1. So here, the derivative of this, we would have to use the quotient rule and the product rule and the chain rule, and it would just become a mess. But using our rules of logarithms, we can separate this fraction and this product in order to make it a little easier for ourselves. So I can take the natural log of both sides. So I would have the natural log of y equals the natural log of the cube root of x squared minus 2 all over 3x minus 1 times the square root of 2x plus 1. Now, I'm going to use my rules of logarithms to separate all of this. So I'll still have the natural log of y equals, this is the cube root, which is the same as the 1/3 power, so it'd be 1/3 natural log of x squared minus 2 minus, this one here would be natural log of 3x minus 1 minus, this has a 1/2 power on the square root of 2x plus 1, so it'd be minus 1/2 natural log of 2x plus 1. Now I can go ahead and take the derivative of each one of these, and it's much easier. So the derivative of the natural log of y using implicit differentiation would be 1 over y dy dx equals, now the 1/3 will tag along, the derivative of the natural log of x squared minus 2 would be 1 over x squared minus 2 times the derivative of x squared minus 2, which is 2x. Then I have minus the derivative of the natural log of 3x minus 1 would be 1 over 3x minus 1 times 3. Then I have my minus 1/2 times the derivative of the natural log of 2x plus 1, which would be 1 over 2x plus 1 times 2. So now we need to simplify for dy dx. So I'd have dy dx equals, I'm going to multiply both sides by y, and I'm just going to go through. and simplify each one of these fractions. So I would have 2x all over 3 times x squared minus 2 minus 3 all over 3x minus 1 minus 1 over 2x plus 1 because my 2's cancel. The last thing is this all has to be in terms of x. So I would replace y with what it equals. So if you remember at the beginning, y equals this entire thing. So I would replace this y here with that entire fraction. So I would have dy dx equals the cube root of x squared minus 2 all over 3x minus 1 times the square root of 2x plus 1. And this is all multiplied by 2x all over 3 times x squared minus 2 minus 3 over 3x minus 1 minus 1 all over 2x plus 1. So as your exit card, we want you to go ahead and try to do these two problems. So compute the derivative of the following. Y equals x to the natural log of x, and y equals x plus 3 squared times the square root of 3x minus 1 all over 2x plus 5. And we'll revisit this in class.